Hello there, you beautiful people, and welcome to this section of the Python Bible on functions. Functions allow you to break up your program into little reusable pieces of code and make keeping your code organized much easier. We've been using Python functions all the time throughout this course, and in this section, you're going to learn how to make your own. This section is going to show you what functions are and how they work, and we're also going to tie together everything we've learned so far in the course into a really awesome project where you're going to make a game of tic-tac-toe, also known as noughts and crosses. Whatever you want to call it, it's this game right here. This project is really going to show off your newfound proficiency as a Python programmer, and by the end of the section, you will have actually made a game. Epic, right? So by the end of this section, you're going to be the master of Python functions, so let's jump right in, and I'll see you in the next video. Hello there, you beautiful people, and welcome to your very first lecture on Python functions. This is going to be a complete game changer of a lecture for you, and it's going to really open up a lot of the possibilities for what you can build, and it's really going to deepen your understanding of how Python actually works. So in this lecture, you're going to learn what functions are, how they work, and how to create them for yourself. And by the end of this lecture, you're going to know all about defining functions, returning values, and also how to pass arguments and parameters into functions. If that all sounds like a foreign language to you, then you're in the right place. Let's get into it. So what the heck is a function? Well, a function is a block of organized and reusable code that performs an action or gives some result. Okay, so let's just jump right in and make one that simply adds together two numbers. Functions are made by defining them. Okay, you have to define a function, and to define a function, you use the def keyword, like this. So I just type def. Now let's say we wanted to create a function called add, and it takes two numbers. Whatever they might be, we're just going to call them x and y. So we type def add, and then open some parentheses or some brackets, and type x, comma, y, and close the brackets. Then type a colon. Okay? Now, def tells Python, the def keyword tells Python that we are defining a function. Add is the function name, and whatever is inside these brackets, inside these parentheses, are parameters to the function. They're called parameters. These are basically what pieces of information you need to give the function in order for it to work. So in our case, in order to add two numbers together, we need two numbers, right? X and y. These parameters can be called whatever you like. I could have called this tuna and apple, right? But that doesn't really make much sense. But you can call parameters whatever you like, as long as you separate them with a comma. So x comma y, like that. And you stick to Python variable naming rules. So they can't start with a number. They can't have spaces in them. You know, just as you would normally name a variable, just name them the same way. So now inside the function, we're going to type some code that we need in order to perform the operation that's going to add two numbers together, right? So if we want to add together x and y, we're just going to type x plus y, right? And that's it. That's our very first function. We use the def keyword to define a function called add, and add takes two parameters, x and y. The function then simply computes x plus y. So if x was 5 and y was 10, the add function would do 5 plus 10, which is 15. So let's see it in action. So now to get our function to run, we need to call the function. Okay, it's called calling a function. So the way that we can make this work is if we did add, just type the function name, and then you type in your parameters. So let's say we want to add together 5 and 10. Okay, now actually you may not have noticed it, but so let me just go back and show you. If I type in add and open the brackets, you can see this little pop-up come up here. That's Python telling us what parameters we might need. So we need two numbers, let's just say 5 and 10. So that's something quite useful. Now when I press enter, now why didn't that work? Well, this was an intentional mistake to highlight something really important when you work with functions. If you want to get something out of a function, the function needs to return a value to you. Okay, sometimes you just want the function to do something. It doesn't need to actually give you back a value or give you back anything. It just needs to do something. Those you don't need to return anything, but we want to get the answer back. Okay, we want to get the answer back, so we need to return whatever this is, whatever this number is here. So the way that we do that is we use the return keyword. We type return x plus y. Okay, now I'm just going to make sure I've got my indentation right. Oops. Let me just get rid of this and start again. Def add x and y, return x plus y. Okay, now when we call the function add 5 and 10, you can see that it returns back to us the number 15, which is fantastic. Now, because this function actually returned a value, we can store that value inside of a variable to use later. So for example, if I had answer equals add 120, now when I press enter, if I show you what answer is, we can see that answer is 120. Now that's awesome, right? We can use functions to do procedures. We didn't have to code this again, okay? We just had to code the function once and it will give us the correct answer every time. Functions, this is why functions are used to make your code nice and reusable. It's got the idea of write it once, use it over and over and over again, which makes them incredibly powerful. So that's pretty sweet, right? Now there's an incredibly important point that I want to show you, as it's a very common mistake when using functions, especially if you're a beginner, okay? The point is returning values is not the same as printing, okay? I'll say that again. Returning values is not the same as printing. So let me show you what I mean. If I change our function, okay, if I change our function here, and instead of saying return x plus y, I print x plus y, okay? Now, when I run it, let's say if I just add, oops, in capital, let's say if I just add 5 and 2, you see we get back 7. We see 7, right? But if I try to store that value in a variable, like answer equals add 5 and 2, we see 7 comes up, but if I try to look at answer, nothing comes up. If I actually look at the type of answer, we see none, right? It's empty. And the reason is print just showed the value on the screen. It didn't do the required processing to store the result under a variable name in the computer's memory. So watch out for that. Print, in general, just if you're going to assign it something, it always returns none, right? So if I had a equals print hello, right? And I look now at type of a, we're going to see that it's none. Print doesn't return anything. It just shows things on the screen. So watch out for that, as it's a very common mistake for beginners. So I'll mention the point one more time. Returning is not the same as printing. Okay, I think we've got that now. All right, let's make another function. So what if I wanted to use a function that would take in some text and write it backwards? Well, in Python, you can reverse iterable data types with a neat trick using slices. So let's say I had a word, and it contained the string, let's say the word was just pen, okay? Now, to reverse it, all I'd have to do, using slices, is type word, open my square brackets, colon, colon, -1. And we see nep come back, which is pen written backwards. So let's define a function that can use that. And by the way, this trick here is magic, but totally amazing. Now, as a challenge for you, go ahead and create a function called rev, so R-E-V, and let it take in a parameter called text. Then, using the trick that I just showed you, return the reverse text of whatever they put in. So pause the video now and have a go at creating your own function, then come back and see how you did. How'd you get on? Did it go okay? Well, here's how I'd have done it. I'd have typed def rev, and we're going to take in a parameter called text, like I said. So we're going to type in there text. Remember, this can be called whatever we want. This could be called bananas, right? But I'm going to call it text. So what we're going to do, if I just typed text plus plus -1, that's good enough, but we want to get the value out, okay? So we need to return the value, not print it. Now, if I run this, so let me just click that enter. We've now defined that function properly. And if I run this and I type rev and I give it the parameter of pen, we're going to see that we get nep back. Now, this is also going to work with lists, right? Because this trick that I showed you here just works for Python iterables. So I could type in rev of, let's have a list 1, 2, 3, 4. And it's going to give us back 4, 3, 2, 1. So fabulous. We now have a function that can reverse any Python iterable. And the best part is it only took 2 lines of code. Awesome. So if you got that right and you followed through with that challenge right there, you're well on your way to becoming a Python function master, which is a cool thing, I promise. So I think we'll have a break there and just have a quick review of what we've learned so far. So first of all, you learn that functions are pieces of reusable code. They take inputs sometimes, and those are called parameters, and they sometimes return an output for you to store in a variable and use later. Now after that, we jumped right in and actually made a function that adds together two numbers. We learned the difference between returning and printing, and why returning values from functions is important if you want to use the value the function gives you back later. After that, you learned that functions can work on any data type really, and we made a function that can reverse any iterable using this slicing trick, and it will give it back in its new reversed form for us to use in any variable later on. So okay, great. Now that you know how functions work, we define them, give them a name, and give them appropriate parameters and some code, and have a return statement if necessary. We're going to dive a bit deeper into what happens to the values you pass into the functions when they are actually inside the function itself. Now, functions can hide certain pieces of information from the outside world using something called variable scope. Now, this is an incredibly important concept, and it's really instrumental to how you'll work with functions in the future. So up next, you've got a quick coding challenge to check your understanding of functions so far, and after that, we're going to jump right in to discussing variable scope. You're not going to want to miss this, so I'll see you in the next video. Hello there, you beautiful people, and congratulations on finishing that last coding challenge, and welcome to this video on variable scope. Now, scope is a very useful programming concept that allows you to keep certain parts of your program from interfering with others, and it's especially applicable to Python functions. Now, knowing how to use scope can make your life easier, but not understanding it can have you scratching your head wondering where it all went wrong. So in this lecture, we're going to take a deep dive into the world of variable scope and how it applies to Python functions. By the end of this video, you're going to know what variable scope is and why it matters. So without further ado, let's get into it. So the first concept you need to understand is that there are only really two types of variable scope in Python. The first, there's one big global scope, okay, and there are multiple little local scopes. Now, if a variable is in the global scope, it's called a global variable and can be seen anywhere in your program. Now, on the other hand, if a variable is in local scope, it's called a local variable and can only be seen within the specific local scope that it's in. In Python, functions create local scopes, whereas loops and if statements don't. So let me show you an example. I'm first going to open a new script called scope.py. Okay, so file, save as on the desktop, Python Bible, scope.py, save it, maximize it, and we're good to go. So inside here, right at the top, I'm going to create a variable called a and set it equal to 100. Now I'm going to make two functions called f1 and f2. So define f1. It's not going to take any parameters. Parameters are optional depending on the function. And we're going to print a. Okay. Then I'm going to do exactly the same for f2. And we're going to print a. Okay. Now when I run both of these, so I'm going to do f1 and f2. This is going to call f1 and then f2. And when I run it, we're going to see that 100 gets printed out twice. Awesome. Now, why does this happen? Well, the reason why this happened is because A has global scope and was therefore visible inside both of these functions. And by that, I mean global variables are visible everywhere inside your program. And therefore, these functions could see the variable A. Now, watch what happens if I move A's definition inside of function 1 using just a cut and paste there. So we now define a inside function 1. When I save and run this, we now get an error, right? We get an error because function 2 can't see the variable a. It says here, look, error in function 2, name a is not defined. And the reason for that is because the variable a was outside of f2's scope, because a is in f1's local scope, and therefore f2 can't see it. So an important thing to know is that functions always create local scopes inside themselves. So f1 has its own local scope and f2 has its own local scope, and neither function can see what is inside the other function. In the previous example, they could only see A because A was global and therefore visible to everything. So imagine this local scope being like a little bubble for each of the functions, and whatever's inside is protected, and anything global outside can also come inside the bubble. Now, if I recreate f2 like this, okay, I'm going to go inside f2 and I'm going to say A is 50. Okay, now we can see if I save and run this that both functions work, but they give a different answer, even though they both use, if I can open up the thing, they both use a variable called A. And this is because the different local scopes that each function has. Local scopes, as I say, are like little bubbles. And the benefit of using local scopes is, imagine if I had 50 functions in an epic beast of a program, right? I wouldn't need to worry about making up a new variable name every time I wanted to use the functions, in case I overwrite something, right? I might be concerned about overwriting a variable. All I need to do is make sure that the variable scopes don't overlap, which is much easier to deal with. Now check this out, it's pretty crazy. What if I create A at the very top here in the global scope to be 250, okay? And I redefine A in each of the local scopes. Okay, so I say A equals 250, then in F1 I say A is 100, and in F2 I say A is 50. Okay, now I'm going to run function 1, run function 2, and I'm also going to print A. Okay, so whatever A is finally is going to be shown there. Now when I run this, we're going to see that function 1 prints 100 as expected, function 2 prints 50 as expected, but down here A is still 250. So why didn't A change even though I was overwriting it in each of these functions, right? It was first 250, I said make it 100 and print it, make it 50 and print it, but down here it's still 250. Well, this is because when you try to change a global variable from inside a local scope, Python stops that from happening and automatically creates a local variable with the same name. So in F1, we didn't actually change A up here. Python created a local variable called A and set that inside the function because Python thought, I don't want them changing the global variable because that could cause problems. And the same thing happened in F2. We didn't change A up here and we didn't change the A here. Python actually created a local variable called A inside function 2, made that 50, and then printed that. So finally, because the global value of 250 was protected, that is what was printed when we printed A down here. So to recap that main point there, you can't change global variables inside of functions automatically. And by the way, in case you're curious, these local variables are destroyed when the function finishes. Okay, so Python gives the variable some memory space. When the functions run, it just removes that variable from memory. So now you can't change global variables from inside functions automatically, but you can use the global value as long as you don't change it. You can use it, but not change it automatically. So for example, let me create a variable called B and set that equal to A plus 10 inside of here. So what I'm going to do is I'm going to say B is equal to A plus 10. Okay, and I'm going to print B in here. Now I'm going to leave F2 the same, and I'm going to keep all this the same. Now what we're going to see when it runs, oh my goodness, it's slow. Okay, so now we're going to see that function 1 actually printed 260. Function 2 just printed its local variable, and the global variable was printed here. So you can see that function 1, it looked inside of itself and it said, I can't see inside of my local scope a variable called A. So it looked outside into the global scope and was like, aha, I see a variable there called A. I'm going to use that. So it had 250 here. And then it did 250 plus 10, and that was 260. Saved that in B, and then printed 260 out, which is what we see right here. Okay. Now with function 2, we defined A as 50. Python was like, okay, we're not going to let you overwrite the global variable. We're just going to create a local variable, and it printed that. And because the global variable was protected, when we printed it out, it still had its original value of 250, which is what we see there. Now, in the interest of time, I'm going to cut this video short here, and we'll continue discussing about variable scope in the next video. But just to hammer home the points that you've learned in this video, there is global and local scopes. Okay, functions create local scopes, and everything inside of a local scope is only visible within its own little bubble. Global variables are visible from everywhere, and they can be accessed from everywhere, but they cannot by default be changed from inside a local scope. If you want to change a global variable, you either have to be in the global scope, or you can use a trick that I'm going to show you in the next video. So I'll see you in the next video to finish up our discussion of variable scope. Hello there, you beautiful people, and welcome back. So what we learned in the last video was that if you have a global variable, you can use that value inside of a local scope, and Python's going to be totally fine with that. But until you try to change that global variable, at that point, Python's going to stop you, and it's going to create its own local variable inside the function with the same name. So here, where I had b equals a plus 10, that's fine, because Python is going to say, oh, okay, he just wants to use that value and save it use it and save the answer somewhere else. That's fine. But here, they're trying to redefine a, it's allowed, but what Python's going to do is it's going to create a local variable called a, and that is completely different from the global one up here. Now that's the default. In this video, I'm going to show you how you can actually use this, how you can actually basically overwrite a global value from inside a function. And the way that you can do that, if you absolutely want to, is to use the global keyword. Okay, and let me just up here, I'm going to type global a, and I'm going to say a equals 100. Now I do need to have two separate lines for this. I can't say global a equals 100. Okay, I have to say global a to let Python know, hey, I'm going to change the global variable called a. It's sometime soon. Then I do it. I say a equals 100. Then I print a. Okay, so what's going to happen is we start off with an original global value. We say Python, we're going to change it. Watch out. And we're going to set it equal to 100 and print it. And then let's just show you what happens. Okay, so what we see is we get 100, 50, 100. And the reason we got the 50 in the middle, okay, actually, let's just start from the top. We had a global variable called a, okay? We then say to Python, hey, I'm going to change it with this global a statement. We then change it to 100 and print it. Now in function 2, because we didn't type global a, the same rules apply the same default rules apply, I should say, in that Python is going to see that you're trying to overwrite a global variable, and it's going to protect itself, and it's going to stop you from doing that. Okay, so this is just going to create a local variable called a inside the function f2. So this is going to be local. This is going to be the global value. Okay, we then print, we then do f1, which is going to print the global value. We then do f2, which is going to print the local value. Then we print the global value again, and we see that we see the global value as 100. It's been changed in function 1. We then print the local value of 50, and again we print the new value of global A. It was 250, but because we changed it in function 1, it has now been changed to 100 down here. So I hope that makes sense, okay? By using the global keyword and defining what variables you want to access, you can override the default protection. And bear in mind, you can't write, again, I know I said it, but you can't write global A equals 100, okay? If I do that, it's going to say invalid syntax, and it's just not going to run. You have to type global A and A equals 100. Now that will work. So there's a slightly special case of these rules, and that's when you use lists or dictionaries. Okay, so let's say I change A, instead of being a number, I change A to be 1, 2, 3. Okay, I'm going to get rid of this, that global statement, and I'm going to just say in here, I'm going to try and set A to be 10. Okay, we're going to see that, as usual, the global value is protected, okay, because it just will. We can't overwrite the whole list. However, what we can do is, without using the global keyword, I can change a little piece of it, okay? So let me say I want to change the first number to 5. Now watch what happens here. You can see that the first value has been changed to 5 in function 1. Function 2 stayed the same because we tried to overwrite the whole list, but you can see that the global value has also been changed just because we overwrit a little bit of it. And we didn't have to use the global keyword. So do watch out for that, because that can trip you up, and it's strange behavior, and it works the same for a dictionary. So do watch out for this when you're working with lists and dictionaries. And awesome, I mean, that's pretty much everything you're going to need to know about variable scope. However, it can be confusing, so let's just have a nice recap of what we've learned, okay, in the past few lessons. The first thing you learned was that there are 2 types of scope, okay? You know, there's 2 types of scope. There's global and local. Now, Python functions create local scopes, okay? But loops and if statements don't, okay? Just the functions do. And you saw that global variables are visible everywhere, and you could define a variable called A in the global scope, and everything inside the local scopes will be able to see it. And they can use that value as well. They could print it out if they wanted. So let's say if I got rid of this, we could, as usual, print it out. And that's going to, every local scope can access the global functions, global variables. The difference is you can't overwrite a global value from inside a local function. Or local scope, sorry. And what happens instead is Python, if it sees you wanting to overwrite a global value, it's going to block you unless, and it's going to create a local variable with the same name, unless you use the global keyword. So let's say I type global A, and I said A equals 100. This is going to now overwrite for everyone the value to be 100, and we're going to see that that's going to propagate through all 3. Now, the exception to this is when you're using lists or dictionaries, and they also do not let you overwrite the whole thing, but without using the global keyword, you can, in fact, overwrite a little piece of it. So I could say A0 is 5, and that is going to, as well, change for all 3 functions. So I hope that makes sense. It's quite a lot of stuff to take in, so don't worry if you have to rewatch these videos a few times if you're still a bit confused, as it is a rather confusing topic. Just watch it again, take good notes, and try it out for yourself. I mean, that's the best way to learn it, right? And I'm sure you'll have a eureka moment sometime soon. And it's well worth learning this properly rather than skipping it and ending up confused for hours and hours when your program breaks or does something unexpected in the future. So just spend the time now, get the concept down, and you'll thank yourself later. So if you do feel comfortable with all of that, next we're going to be coming on to the difference between function arguments and function parameters, which is a critical thing, and it's very important you need to know about. So I'll see you in the next video. Hello there, you beautiful people, and welcome to this lecture on keyword arguments and default parameters for functions. So we first can have a quick discussion of what a function parameter is, and also what the difference is between function parameters and function arguments. This is a problem known to keep many people in the programming community up at night, but it's rather simple really. After that, we're going to learn how to use keyword arguments and also how to use default parameters so that we can make our functions much more flexible to use. And by the end of this lecture, you're going to know the difference between a function argument and a function parameter, which is always good at parties, and you're going to be able to give your functions default values. So let's get into it. So let's go ahead and make a function that's going to tell us about someone. We're going to use the def keyword, which is short for define. Our function is going to be called about, and we're going to give it 3 parameters. We're going to give them the person's name, their age, and their likes. Okay, now what we're going to do, we're going to make, first of all, we're going to have a local variable called sentence, and we're going to say meet blank. They are blank years old, and they like blank. And we're going to format in there their name, their age, and their likes. Okay, awesome. And we just want to return that sentence. Okay, so to call this function, we'd use about, and let's say we're going to say the person's name is Jack, they're 23, and they like Python. And we're going to say it says meet Jack, they're 23 years old, and they like Python. Brilliant. So here we can clearly see the difference between a function argument and a function parameter. The parameter is what we use in the function definition. So the parameters in this case would be name, age, and likes. Those would be our parameters. But the arguments are what we actually pass to the function, or what we give to the function when we call it. So here our arguments are Jack, 23, and Python. The argument Jack matches to the parameter name. The argument 23 matches to the parameter age. And the argument Python matches to the parameter likes. And the reason it does that is because we type them in a specific order. But we can enter our arguments in any order we like, as long as we make it clear which parameter they associate with. And when we do that, they become keyword arguments. So let me show you what I mean. Instead of typing it like this, which requires every one of them to be in the correct order, what we could do is we could say age equals 23, comma, name equals Jack, comma, what was the other one? Likes equals Python. And when I run that, it's going to give us exactly the same thing, but you can see we've got some flexibility in the order. These are keyword arguments because each argument is associated with a keyword which matches the parameter in the function definition. Now this is all fine, but what if we didn't want to give a specific value, but we still wanted the function to work? I mean, maybe we didn't know what the person liked, for example, but we knew their name and age. I might be able to change the order, but at the moment I have to enter 3 arguments. If I didn't, let's say I just took out their likes like that, and I just tried to type in Jack23, we're going to get an error, and it's going to say the about function is missing one required positional argument, and it's missing likes. By the way, when I said that these things have to be in a certain order, those are called positional arguments. When we give them the keyword, they're called keyword arguments. They're basically the same thing, it's just one has more flexibility than the other. So how can we actually make this function run without having to give the likes? But we still want to be able to do something with it, right? We still want to be able to process the likes if we've got that information, but if not, we still want the function to run. Well, to do this, we have to give the function, we have to give the likes parameter a default value. So if we don't give it if we don't give the function what that person likes, it's going to default to another value. Okay, and the way that we can do this is I'm going to take my function definition down here, and what we do is in this function definition, under the one that you want to give a default value, you use a equals sign, and let's say by default that person is going to, everyone that uses this function is going to like Python, because who doesn't like Python, right? So that is going to set the likes value by default to be Python. So now when I use about, I can type Jack, and his age is going to be 23, and by default you can see meet Jack, they are 23 years old and they like Python, even though I didn't enter it. But if I do enter it, let's say they like football, which is a lot more realistic, isn't it? If I do that, meet Jack, they're 23 years old and they like football. So now we have a lot of flexibility. We can enter that value or not. But there's something rather important to know when you're dealing with default values. Default parameters must go at the end. Okay, so for example, I couldn't, when I was defining the thing, I couldn't say name equals, let's say by default their name is Jack, and then after it I just have these two ones without default values. No, I'd have to put age, then likes, and then put the name. Okay, I'd have to do it like that. Your parameters with default values have to go last. So I'm just going to put that to the way that it was before. And I can have as many default parameters as I want. Obviously, I could have, let's say, okay, they like Python. Let's say I had hair color. Right? I could set that to a default value there, and you can have as many of those as you want, but as long as your default values come last. So just bear that in mind. So watch this as well. If what I can do is, if I gave all of them default values, let's say the default name was Ziad, the default age was 23, and the default likes was Python. Okay, so let me define that function again. Now I can, if I want, I could say about, let's say we want Jack, he's going to be 29 and he likes football. Okay, that's going to work just fine. But if I just call about with no parameters or no arguments in this, no arguments, it's not parameters, hit with no arguments, then I can press enter and it's going to use all of the defaults. So that's quite awesome, right? Your function's going to work whether you give it information or not. This is a general case and that gives you a lot of flexibility. So you're going to want to hang on to that. And that brings us to the end of this lecture on default parameters. So let's just have a quick recap of what we've learned. We started off with a discussion of what a function parameter is and why they're different to function arguments. You learned that parameters are what are in the function definition and arguments are what you actually pass the function when you call it. After that, you saw how to use keyword arguments when passing arguments to your functions so that you can enter your arguments in any order that you like, which is opposed to positional arguments which have to be put in the correct order. You also saw that you can actually leave out certain arguments as long as you have a default parameter in your function definition. And you can have as many default parameters as you want, as long as you put those default parameters after the non-default parameters when you define the function. So like up here, likes had to go last. And there you have it. You now understand the difference between a function argument and function parameters, and you can use keyword arguments and default values in your functions at will. So check you out. Now, in the next lecture, you're going to be learning techniques that will make entering arguments to functions much easier, especially when you have a lot of them. And also when your functions get a lot more complicated, this is going to come in really useful. So you're not going to want to miss this, and I'll see you in the next video. Hello there, you beautiful people, and welcome to this lecture on packing and unpacking variables. Now, sometimes entering values into a function is a bit restricting or a downright pain. Now, in this video, you're going to learn some tricks that's going to make working with functions an absolute dream, especially when they get quite complicated. So the concepts we're going to be looking at might be a bit tricky, but I'll try my hardest to simplify them as much as possible. We're going to look at the concepts of packing and unpacking variables, and while potentially difficult to grasp, these are incredibly useful concepts. We're going to look at unpacking arguments and packing arguments, as well as unpacking and packing keyword arguments. So after this lecture, you're going to be able to make much more flexible functions, and also using functions should be a lot easier for you as well as your projects get bigger and bigger. So let's get into it. Okay, so first of all, let's check out how to unpack arguments. To show you this, I'm going to use the simple print function. If we do print of 1, 2, 3, 4, 5, you can see that we're passing in 5 arguments to the print function, and it's just going to print them all out on one row. Okay, now if I have a list of numbers and I put in there 1, 2, 3, 4, 5, if I print numbers, yeah, we're just going to see a list pop up, okay, because we've passed one argument to the print function, which was just one list. Now, if I unpack the list before we print it, like this, okay, we're going to put numbers in there just like normal, but at the front, I'm going to put an asterisk or a star, okay? This is what you use for multiplication. It's the same symbol. So now we're going to unpack the list before we print it. And what happens then? You see we get exactly the same result as earlier on. Okay, so what's happening now when you unpack arguments is that we take each item from an iterable data type, like a list, and each of those items becomes its own argument to the function. So instead of having one big list of 5 numbers, we now have 5 mini arguments, 1 number each. Pretty sweet, right? So you can unpack any iterable data type before they go into functions. So this means this is going to work for strings as well. If I just print ABC, right, I put in one argument to the function, and you see ABC just as one string come to the screen. But if I print the unpacked version of ABC, using this star at the beginning, now we're going to see A, B, C. Okay, that's the same as typing this. Oops. So you can see it unpacks into each individual item as an argument to the function. And you see we get exactly the same thing right there. So that's pretty useful, right? Okay, so the next thing is how to pack arguments. We've done unpacking. How can we pack them? The way this happens is it works inside a function. So let's create a function that adds 2 numbers. So define add x and y, and we're going to return x plus y. Simple, right? Just what we did a few videos ago. Now, if I put 2 numbers in this, okay, this function's going to work great. I can do 10 plus 10, and that's going to work absolutely fine. But it's slightly limited, because this function only has 2 parameters. It won't work for 3 numbers, or 4 numbers, or 5 numbers, and so on. It's only going to work for 2. So what we can do is, instead of putting x and y up here, we can just type this. Okay, we're going to do that. We're going to copy and paste a thing, and I'm just going to pack in as many numbers as possible. Now, what's going to happen is it's going to pack whatever arguments that come in into one tuple called numbers. Okay, and because tuples are iterable, we can loop through them and add them up. So what we can do is we can say total equals 0 for number in numbers, total equals total plus number. Then we're going to return the total. Okay. Now, watch what happens here. Now, I can add in as many numbers as I want. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going to see that's going to give us back 45, which is true. Okay. What happens is all of these arguments get put into a tuple called numbers. It's basically like doing this. It's basically like taking all of this and saving it in a tuple called numbers. Then we loop through that tuple and add them all up and then print out whatever that value is. Okay, so or return back whatever that value is. So we can now add up any amount of numbers. And what we've learned is that packing is very useful when you don't know how many arguments you're actually expecting, and it makes your function a lot more flexible. So instead of just having to define x, y, z, a, b, c, d, e, f, g to take up all the things and taking all the numbers and giving them a default value of 0, for example, if they weren't entered, all we have to do now is just pack them all in to one tuple and loop through the tuple, and that tuple can be as big as we want. So it's given us a lot of flexibility. So that's packing. So what about keyword arguments? Well, keyword arguments, just so you recall, are if you have a function, if I can just get rid of this line, if you have a function like add, okay, and instead of just typing 1 and 2, let's say, where these are positional arguments. So the first thing we've typed is going to become the first parameter, and the second thing we've typed is going to become the second parameter. Keyword arguments would be like this: y equals 1, x equals 2. Okay, so we're saying which parameter this value is. How can we pack and unpack these? Well, we're going to start with unpacking, and this is basically going to, instead of producing, it's basically going to work on the concept of dictionaries. Okay, so let's bring back the function we made previously that tells us about someone. We're going to say define about, name, age, likes, and we're going to have a sentence, meet so-and-so, they are blank years old, and they like blank. And we're going to format their name, their age, and their likes. And then we're going to return that sentence. Okay, so now let's say that we have a dictionary like this. Okay, our dictionary is going to be name, and that's going to correspond to Ziad. We're going to have age, and that's going to correspond to 23. And we're going to have likes, and that's going to correspond to Python. Okay, so we've got a dictionary like that. Now we can unpack this dictionary into this function. And the way that we do that is, instead of just typing 1 star, we type 2 stars because they're keywords. Okay, let's just remember that. 1 star for normal arguments, 2 stars for keyword arguments. And we type the name of the dictionary, which is dictionary here. Now when I show you that, that's going to say meet Ziad, they are 23 years old and they like Python. And the good thing about dictionaries is I can type these in whatever order, right? Because it's the key that is this is becoming the parameter, and this is becoming the argument. This is becoming the parameter, this is becoming the argument. It doesn't matter what order that I put those in, it's still going to work the same. So this is exactly the same as typing about name equals Ziad, age equals 23, or not like that, age equals 23, and likes equals Python. It's exactly the same thing, but you don't have to type it by hand, you see. You can just have some kind of automatically generated data structure and then just pack them all in at once. So that's pretty straightforward, right? Now, for this to be useful, you need to remember that the dictionary will very likely be generated automatically somewhere else in your program, so you won't be typing it out by hand like I just did. That kind of defeats the point. So finally, let's have a look at how you can pack keyword arguments using the double star operator, just like we did here. So I'm going to make us some space, and I'm going to define a function called foo and pass it just one parameter, or give it one parameter called quargs. Now, quargs is just a convention. It's short for keyword arguments. There's another convention as well, where you just have star and args, which is just short for normal arguments, which is what we've been seeing up here. So you know how you see how up here we called it numbers? In the Python community, that would be called args. But, you know, you can call it whatever you want. It's just a convention. So I'm going to stick with double star quargs. Now, when we pack something, when we pack down these keyword arguments, we're going to produce a dictionary out of them. And that dictionary is going to be called quargs. Just like up here, we made a tuple of them. We made a tuple called numbers. Here, we're going to make a dictionary called quargs. And what we want to do, we just want to print and show what the key was and what the value is for that specific, I guess, that specific keyword pair. So what we're going to do is we're going to say for key, comma, value in quargs.items. Okay, this is going to give us basically a set of tuples, and each one is going to have a key and a value, and the key is going to match the key and the value is going to match the value, basically. We just want to print blank, comma, blank, and format in there, the key, and then the value. So now watch what happens if I do foo of Huda equals female and Ziad equals male. We're going to see that that is going to produce a dictionary of these keywords, and then it's going to loop through that dictionary and give us the appropriate format, which is quite neat. So if you've got a bunch of keyword arguments that you don't know what they're even going to be called yet, we didn't define a keyword to be called Huda, we didn't define a keyword to be called Ziad, but this kind of dealt with the whole process. So this could be as long as we wanted. We could have John is going to be male as well. You see that it works in exactly the same way. So that's how you pack down keyword arguments into a dictionary and loop through them. And that's it. Now, I know this is quite a hardcore lecture to digest in just one bite. So have a go at playing it a few times to help it sink in. And also, you know, just have a go. Just jump in there and try it out yourself and see if you can get it to work on your own. You'll learn a lot more by doing. Trust me. Now, let's have a quick review of what we've done in this video to help you remember all of this stuff. First, we use the star operator. And the star operator is used to pack and unpack just regular old iterables. You can pack them into tuples inside of functions, or you can unpack them as arguments when you put them into a function. So the example where we used this was to make the add function. Do you remember where we could add up any amount of numbers that we wanted? So after that, you saw the double star operator, which is exactly the same concept. It works for keyword arguments. Now you can unpack keyword arguments into a dictionary inside of your function, or you can pack them into a dictionary for your function. Okay, so it's going to work in pretty much exactly the same way. It's just it uses a dictionary because there's two pieces of information, right? There's the keyword and the value, whereas before there was just a value. So if it doesn't all make sense in the first time you've gone through this, just watch it again and again, and I promise you'll most likely get it by the third time you see it, I promise. So, and if you aren't following along and trying it out and coding along, then give that a go. Practice makes perfect. Now the next video holds this section's project. It's going to be an XO, tic-tac-toe, or noughts and crosses game, however you want to call it, but it's going to be quite a challenge, and it's going to use almost everything that we know. But it's going to be an amazing feeling to actually play a game that you've actually created yourself, and it's going to be a great testament to just how far you've come by using the Python Bible. So to get started making our game, I'll see you in the next video. Hello there, you beautiful people, and welcome to this project where we're going to be making a game of tic-tac-toe, noughts and crosses, XO, 3 in a row, whatever you want to call it. You've most likely played it, and it's going to be epic. So this is going to be quite an involved project, and it's going to use a lot of what we've done so far. As we're getting towards the end of the course, I'm going to step up the difficulty to show you what's possible and also really use those pieces of the course that perhaps you might have forgotten. So it's going to be a good reminder as well. Now, if you follow along, even though it will be hard, by the end of it, you won't recognize yourself. You'll be so much better at programming Python than you are now, and will have built, with your own hands, a very playable game, and will totally be a great Python programmer. If you're ready, let's jump into it. So I've gone ahead and created a script called game.py in the usual place, and we're going to start off by making the board. So how can we make a board in Python? Well, the board, if we think about it, has 9 spaces, right? 3 columns of 3. So the data type that we need to use to make the board needs to be able to hold multiple things inside of it. So we're going to need a data structure of some sort. So that means if we're going to use a data structure, we're going to use a list, a tuple, or a dictionary. So which one is it? Well, the board can change as, players make moves. So therefore, we can't use tuples because tuples are unchangeable. And the simplest way to access each of the spaces would be to use a number, just to number each of the spaces. And because lists allow us to access elements using numbers, we're going to use a list. So we're ready to go. Our board is going to be just an empty list to start with, and needs to have 9 elements. So what we could do is we could type board equals and give it blank spaces like this 9 times. But I'm quite lazy, right? I don't really want to type that 9 times. So what I'm going to do is I'm going to use a list comprehension. And I'm going to say, give me a blank space for I in range 9. And that's that. Now, I isn't actually being used, but this loop is running 9 times, and it's giving me a blank space. Okay, so that's going to give us a board with 9 blank strings in it. Brilliant. So if I print this board, you should be able to see that. There we are. 1, 2, 3, 4, 5, 6, 7, 8, 9. Told you list comprehensions were useful, right? So let's just close the shell. Okay, so now we have our empty board. But when I run this, right, it doesn't really look like a tic-tac-toe board, right? A tic-tac-toe board is a grid, is a 3x3 grid. So we want to actually see something like that if this game's going to be believable. So let's just head back over to our function. And the way that I'm going to have this board printed is I'm going to use a function, okay? And I'm going to define that function. I'm going to call it print board. Now, to create each of the rows, I'm basically just going to print a string. So row 1 is going to be a string of blank, blank, blank. Now, if you're wondering where I'm getting these, they're called pipe symbols. On my keyboard, it is, I press shift and I press the key next to the letter Z. So it's just above the backslash on my keyboard. Yeah, I can't help you if it's not in that position, but just look for the pipe symbol on your version of your keyboard and you should be able to find it. Now, in each of these, this is going to be the first space of the board. This is going to be the second space of the board. This is going to be the third space of the board. So to do that, I'm going to format board 0, board 1, and board 2. Okay, so that's row 1 as a string. I'm going to copy and paste that onto the next line, making sure the indentation's the same. Did you see how it was indented 1 across? That would mess Python up, okay? Now it has to all be in line. So row 2, it's going to be board 3, board 4, board 5, and one more time. Okay, so row 3, we're going to get board 6, board 7, and board 8. Okay, now to actually make it print out, we're going to print a blank line, print row 1, print row 2, and print row 3, and then finally a blank line underneath the board. And these extra blank lines here are just to make it look nice. Okay, they don't really do anything else. So that's our function. I'm just going to save that. Now when I print the board, when I run the print board function, all of this code's going to run. And what we're going to see is we're going to get our beautiful tic-tac-toe board on the screen. How nice is that? Now, this code is slightly repetitive, right? I could write a for loop to print this out, but because it looks so beautiful, I think we'll leave it just as it is, don't you? Now, down here, we're going to have, instead of this print board, we're going to have a while loop that basically runs forever, so the game will continue to run. This is in game programming, this is called the game loop. Okay, and basically the rest of our code is just going to go inside of this. So player 1 is going to play as X. Now we need to ask them where they would like to place their move. If the player enters 1, they're going to move to the top left. If the player enters, I don't know, if they enter 5, they're going to go here. Okay, if they enter 8, they're going to go here. So just imagine these blank spaces being like the numbers on a telephone. 1, 2, 3, 4, 5, 6, 7, 8, 9. So to ask for this move, we're going to create a variable called choice, and I'm going to ask for the input, enter your move 1 to 9. Okay. Now I'm going to want to strip away any white space, and because these are numbers, I'm also going to convert it to an integer. Okay, so now we're going to get a number of actual integer data type inside this variable here called choice. So we can now update the board with that move. But there's something we need to bear in mind, however. Because of the fact, the way that the Python list, its indexes start from 0, if they enter 1, to move to the top left, we actually need to say that that is board index 0. Okay, so we need to actually enter an X at the index below their choice. So what I mean is, instead of writing board of choice equals X, we actually want to write board of choice minus 1 equals X. So when they enter 1, 1 would be choice, 1 minus 1 is 0, and that is what goes there. Now actually, before we run this, what I'm going to do is actually up here, I'm just going to change this into 2 spaces. And the reason I'm going to do that is just to give a little bit more space inside of our board. So now when I run it, we're going to see our board pops up, and enter your move. Let's say we want to go straight into the middle. Okay, so we're going to 5. Bang, there pops up an X. So what if I want to go at the top right? Type in 3. There that is. And come on, let's just win a cheeky game. Go number 7. And there we go. And we can stop this by pressing Control and C. So that's amazing, right? We've now got a updating board depending on which, when you enter your moves. But what we need to do, we need to make this so that you can only enter a move when that place is empty. Okay, so for that, we're going to need to check whether our board holds an empty space or not. So right here, we're going to say if board of choice minus 1 is 2 blank spaces, because I've got 2 blank spaces up here, then if it's empty, basically we're going to say board of choice minus 1 is going to become an X. But otherwise, print a blank line and say that space is taken. I'm going to remove this extra line of code here and save that. So what's going to happen is now we're going to have our empty lit thing. I'm going to go straight in the middle, and it's going to go fine. But if I try to press the same space again, it's going to say that space is taken, but it still remains our move, which is kind of just like real life. So we've made a lot of progress in the game so far in this video. We've made the board, printed it to the screen, and allowed player 1 to make valid moves. So that's quite great, right? Now up next, we're going to continue working on our game and get player 2 into it. So I'll see you in the next video. Hello there, you beautiful people. So let's continue working on our game. Now in this video, we're going to make it possible to process moves for player 2. Now when we process moves for player 2, it's going to be basically the same as for player 1, right? So what I'm going to do is I'm going to create a function called player move, okay? And the reason I'm creating a function is because I don't want to just be repeating myself. I just kind of want a general function that's going to do a move for a player. And I'm going to give it a parameter called icon, okay? Now inside of here, I'm going to move all of this inside of there, okay? And instead of just printing X for every player, I'm going to print that icon. So, for example, if I did player move and I gave it the icon of X, that would mean that it was the X player moving. And the processing is going to be exactly the same. If it's a blank, then you can put that icon there. And if it's not blank, then the space is taken. It doesn't matter whether it's an X or an O, the game works exactly the same way. So, but one thing we do want to add is we want to tell the player whose turn it is. So let's say print your turn, player, like that. And we're just going to put in the icon. So whatever it is, it might say your turn player X or your turn player icon. Or what we could do, actually, is we could have a an if statement. We could say if icon equals X, number equals 1, else if icon is O, number equals 2, and you go your turn player number. Okay, so now it's going to say your turn player 1 or your turn player 2. So that's good like that. Let's save that. So let's run this. Okay, actually no, let's not run it just yet. First, what we need to do is in here, when we've printed the board, we're going to say player move X. Then we're going to print the board to show what happened, and then we're going to do player move for the O. Now when we run this, okay, it says your turn player 1. We can see that it's moving. We can see this working, right? So let's start with the X, go straight in the middle. Popular tactic that. It's going to say your turn player 2. Let's say we want to move up to the top left. Or top right, sorry. And there you go, actually. So we can see that is working fine. Now we've got an O in that place. Let's say we want to move the X down 1. That's moved there. And then we want to move the O right there. Okay, so we're getting the game's working, right? And if I try to move on top of someone else, let's say I want to move on player 2, it's going to say it's not possible for both of us. So we're doing well. So I hope this highlights to you just how important functions are, right? We've managed to write a function once, but made it general enough that it's worked for 2 players. So I hope that really helps you figure out how useful functions are. Our next step is that we need to check whether someone has won the game or not. So let's make a function called isVictory. Okay, define isVictory. And we're going to give it the icon here. So instead of making a function saying did X win or did O win, we're just going to say is it a victory for that icon. Now how do we know if someone has won? Well, there's 8 ways to win, right? They can have all of row 1, they can have all of row 2, or they can have all of row 3. They can have all of column 1, column 2, or column 3, or they can have either of the 2 diagonals, which makes 8. So this is rather simple to program, it's just a bit repetitive, but copy and paste is going to do the job. So let's check if they won on row 1 first. What we need to do for that, if board 0 is equal to their icon, and board 1 is equal to their icon, and board 2 is equal to their icon, then you know that means they have row 1 and they'll win. But what we're going to need more space for the other 7 conditions. So let's break up this if condition on more than one line, and we can do that by using a backslash. So I'm going to say or, and then type a backslash like that. And you can see the way Python's kept us all nice and in line. So let's do it for the other rows as well. So let's copy and paste this. The second row is going to be board 3, board 4, and board 5. And we're going to say OR, like that. Now let's do the last row. So board 6, board 7, and board 8. Okay, so that's all of the rows. We now need all of the columns. So for all of the columns, what we're going to need for that is we're going to need board 0, 3, and 6 for the first one. So that's column 1. We're going to need, for the next one, we're going to need 1, 4, and 7. Oh, that was fine, actually. 1, 4, and 7. And we're also going to need 2, 5, and 8. 2, 5, and 8. Okay, so now for the diagonals, we are just going to want to have 0, 4, and 8. And for the other diagonal, going to have 2, 4, and 6. All right, so that's how we're going to check if they win. So if either of all these conditions are true, then actually I don't need an OR there. I'm going to put that colon. If either of these conditions are true, we're going to just return true. Otherwise, return false. Okay, so this function is going to give us back true or false. It's going to give us back a Boolean. Now, to make this work in our game, we need to check for a victory after X moves and after O moves. So let's do X first. So X is going to move. We are going to put this here. We're going to say, okay, we should print the board first. So let's check if it's a victory after that. If it's victory for X, we're going to print X wins, X wins, congratulations. And break. And this break is just going to end, it's going to break us out of the while loop, okay? So that's just basically going to finish the game. So if X has a victory, this is going to give us true, which means the condition here is going to be true. Notice how you can use a function to give you a Boolean rather than just using a normal conditional operator, which is a really useful thing because you can define how you're going to get your Booleans depending on the conditions that you want. So if X wins, this is going to be true and this code will run. If not, we're just going to let player O move. So the only difference now when player O moves is purely for formatting reasons. We're going to need to put a print board inside of this victory condition. So what we're going to do, just purely for formatting things, so let's just pull this over one. Again, make sure the indentation is right. Actually, no, sorry, that needs to be in there. That does need to be in there, inside the if statement. Now, inside of here, we're going to put a print board. We're going to check the O victory, and we're going to say O wins. Okay, so let's have a look, see how that works. So we're going to say X is going to go there, O is going to go there, X is going to go there, O is going to go there, and then X is going to win by just going on 8. And it's going to say X wins, congratulations, and the game will finish. And hopefully the same is going to work for the O, so let's check that. Okay, so we're going to have X is going to go in number 1, O is going to go number 2, X is going to go number 3, O is going to go 5, X is going to go at 6, and O is going to go in 8, and it's going to say O wins, congratulations, and show us the thing. So fabulous, we have now have a fully working game. But one thing that we know that happens quite a lot in the game of XO is that there's draws. Okay, so you just, most of the time, the game draws. And so we need to make another function called isDraw. def is draw. And how do you know if there's a draw? Well, the game draws when there's no space left, right? So what we're going to do is we're just going to say if the double space is not in the board, then, by the way, is that going to work? Yes, it will, because we've defined the board as global, right? So the global variable is going to be in here. If double space is not in the board, then return true, because that means the board's full. Otherwise, return false. Simple as that. So we're going to check for the X victory. We're going to check for the O victory. And then right at the end here, we're just going to say if is draw. Oh, sorry, we're going to say, actually, we're going to, yeah, we're just going to check here, elif is draw. We're going to say print, it's a draw, and we're going to break. So the reason I put it here is because X could move, not win, and the board be full. Okay, so we need to check if the board is full before we let player O have a go, because otherwise the player O could be playing on an already full board. And I'm going to do exactly the same down here. Okay, so we're going to let O move. If he wins, then great. If it's a draw, then stop the game. Otherwise, just go around and let X have a go. So awesome. We know if I run this, that should be pretty much a fully working game. Let's have a look here. 1 is going to go there. I'm just going to type in random numbers, to be fair with you, see what happens. He's going to need to go there. He's going to need to go there. Let's say 6. He's going to go there. He's going to go in number 7 to block him, and then number 9. And it's going to say it's a draw, which it is, because now the game is completely full up and there's no spaces left. So that's working. I mean, that's pretty awesome, right? You now have a game that you can actually play with your friends, EXO, that you programmed yourself. So there's plenty of things we could add to this. We could tidy up our code a bit, or we could get the screen to clear itself so we only have one board on it at a time. But I'll leave them for you if you want to program them on your own, rather than dragging everyone through it if they don't. So in general, this is a really quite an awesome project, right? This is something much different to what we've done before, which has normally just been printing stuff to the screen. So you should be super proud of yourself for building this. So why not reward yourself by grabbing a friend or loved one and playing a good old game of tic-tac-toe. Either way, that brings us to the end of this section of the Python Bible on functions. In the next lecture, you can have a review of what we've learned and also get a taster for what's to come in the section on classes, which is going to be all about object-oriented programming, and it's going to take your Python skills to really a massive next level, like industrial level. So I'll see you in the next video. Hello there, you beautiful people, and welcome to this section review lecture for this section of the Python Bible, all about functions. We've really covered a lot of stuff in this section, and hopefully you now have a good idea of how functions are used in Python. Just to make sure that it's all stuck in your head, we're going to do a quick recap, and after that I'm going to introduce you to the next section of the course on object-oriented programming. So let's get into our review. The first thing we learned is that functions are a piece of reusable code that performs an action or give some result. You made your first Python function that simply added together two numbers and returned us a value. You learned that the return keyword is how you return values from functions, and you use this to store the result of a function operation for later. Most importantly, you learned that returning is not the same as printing. Returning a value lets you store that value in a variable to use later, whereas printing just puts text on the screen. You then smashed a coding challenge, and after that we started talking about variable scope. You learned that there are two main types of scope. There's global scope and local scope. Functions create local scopes inside of themselves, and this acts like its own little bubble. You learned that global variables can be viewed anywhere in your program, but local variables can only be seen inside their local scope. This saves us from having to worry about whether all of our variable names are unique all the way through our program. You can reuse variable names as long as they're unique within their own scope, and you won't overwrite any of your data, which is pretty nice. You also learned that when you try to change a global variable from inside a local scope, Python just makes a local variable with the same name. If you want to change the global variable, you need to use the global keyword. However, you also learned that you can change little pieces of global lists and dictionaries from a local scope, although you can't overwrite the whole thing. After that, you learned the difference between a function argument and a function parameter. Parameters are what you define in the function definition, and arguments are what you pass to functions when you call them. You also learned how to give your function parameters default values to give yourself more flexibility when using your functions, and you also learned the difference between positional arguments and keyword arguments. Positional arguments are based on the order that they're entered, and keyword arguments are entered with certain keywords. Name equals Jack or age equals 15, for example. You then learn how to pack and unpack arguments and keyword arguments, or args and quargs, using the star and double star syntax. Finally, we made a game of 3 in a row using all of our skills from the very beginning of the course, and this gave us a good grounding in just how powerful functions are for building real-life programs. So whatever way you look at it, that is a lot of stuff. And if you look back on where you started with this course and where you are now, it's hard to believe you're the same person. Your transformation has been completely and utterly inspirational, so well done to you if you've been following along. But we aren't there yet. Up next, we're going to be talking about how to use Python for object-oriented programming. Object-oriented programming, or OOP, is an extremely common programming methodology that allows you to build incredibly powerful programs by just thinking of things in your code as real-life objects. I won't spoil too much here, so I'll see you in the next video.